Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on August 5th, 2025, so just yesterday. This paper introduces a new training framework that allows its 32 billion parameter model to actually surpass Claude 3.7 on the difficult task of function-level bug localization. The paper is titled Tool-Integrated Reinforcement Learning for Repo Deep Search, and the implications for automated software development are pretty significant. The authors achieve this using a two-stage training method called ToolTrain, which combines supervised learning with reinforcement learning to teach models how to better use tools to navigate code. Also, the authors shared their implementation on GitHub. In the repository, you'll find scripts for the entire pipeline, from the supervised fine-tuning and reinforcement learning stages, all the way through to running inference and evaluation on the benchmarks. It looks pretty complete. Alright, so to get a better sense of how this works, the authors designed a lightweight agent they call RepoSearcher. This diagram shows its workflow. It all kicks off with a software issue, which is fed to the LLM. The core of this process is an iterative loop. The model thinks, makes a tool call to search the code repository, and gets back some context to inform its next step. Once it's gathered enough information, it calls an exit tool and points to the specific faulty files and functions. So this table then details the specific tools the RepoSearcher agent has at its disposal. You can see there are 6 of them, and they're designed to be pretty straightforward. Well, tools like get repo structure and get import a file help the agent get a high-level view of the project's architecture. Then, for a more detailed look, it can use search class, search function, or search class method to inspect specific code snippets. Once it has what it needs, it just calls the exit tool to finish up. Okay, so this diagram shows the core of the whole approach, the two-stage ToolTrain framework. The first stage is a warm-up using supervised fine-tuning. As shown at the top, the model tries to solve an issue, and only the successful attempts are kept for training. The failures are just thrown away. The second stage uses reinforcement learning. Here, the model generates multiple attempts, which are then scored based on the quality and ranking of the answers. This scoring provides rich feedback, helping the model learn more complex strategies. Moving to the results, this table breaks down performance on the SWE bench-verified dataset. The authors focus on several metrics, but let's look at function-level recall at 5. This metric checks if the correct faulty function is in the model's top 5 suggestions. And here, the results are quite impressive. The ToolTrain 32B model, highlighted in blue, scores 68.55, which actually surpasses the 66.38 from the much larger Claude 3.7 Sonnet model. This shows the training really pays off. To figure out why their method works so well, the authors performed an ablation study, which is where you test different components to see what's most important. The top chart shows this for the 7B models, and the bottom chart shows the same comparison for the 32B models. In both plots, the purple bar, representing the full ToolTrain method, is consistently the highest. This confirms that combining both supervised fine-tuning and reinforcement learning is the key to its success, outperforming either strategy used alone. So the big question is, does better localization actually help fix more bugs? Well, this table answers that directly. Looking at the final column, %resolved, we can see the real-world impact. The RepoSearcher framework with the ToolTrain 32B model achieves a 31.60% resolution rate. That's the best result here, confirming that accurately finding the problem area is a critical step for successfully generating a fix. Alright, so to wrap up, the ToolTrain framework provides a powerful strategy for teaching LLMs how to navigate complex codebases. This targeted training for issue localization leads directly to better automated bug fixing. That's it for this episode.